All right, well, let's look at our second special case. Let's say they have equal priorities and now different durations. So we have a longer job and a shorter job. And just so I don't use higher priority and lower priority, and so I don't have, so for the previous I used subscripts of L and H. Here I didn't want to reuse L, so let's say that it's the extended job. The longer job is the extended job. So I have two options. I can schedule them with the shorter job first or the longer job first, or I could do the opposite. I could schedule the longer job first or the shorter job first. So let's do the same thing here. Let's compare these two costs. So we have the cost of the shorter job first, which is the priority, and since the priorities are the same, I'm just going to use P, times the duration of the shorter job, plus the priority of the second job, which is the same, multiplied by the completion time of the second job. How does that compare with the second schedule? I'll do the same thing. We can distribute through. And we can cancel things out. So both sides have a P times ds, and both sides have a P times dE. So now I'm left with P times ds, and compare that times P times dE. The P's can cancel out. And we know that the duration of the shorter job is less than the duration of the longer / extended job. So in this case, it's better to go with the shorter job first. And that should make sense. If I go back to this picture, if I look at the average completion time here, so the first one stops here and the second one stops here, if I were to swap these jobs, all I'm really doing is shifting this first line to the right, which is going to give us a higher average completion time. So now the first job ends here and the second job ends here. And if you notice, I really just moved that first line to the right. Okay, so that's our second special case. And what we found is that it's better to schedule the shortest job first.